So let's try a few more practice Lewis dot structures for ionic compounds. You'll notice again, these are far easier than your covalents, no geometries, right? So the first one says, draw the Lewis dot diagram for a compound between calcium ion and a sulfur ion. Okay, so calcium, oops, let me try that one more time. You know that calcium, again, has two dots because, again, it is an alkaline earth metal. Then we're going to have the sulfur ion. So we're going to add that to a sulfur ion, which has 6. 1, 2, 3, 4, 5, and 6. All right, so if sulfur has 6 and calcium has 2, if we add those together, 6 and 2, then we quite clearly are going to get 8. So for example, this one's going to move right here, this one's going to move right there, and so it's going to get the 8 that it requires, or desires, I should say. Calcium is going to lose both of it, so there's calcium with no dots whatsoever. It's lost both of its electrons, therefore it's a +2 or 2 plus, same thing. And then sulfur had 6. It had 1, 2, 3, 4, 5, 6. It got one more from the calcium and another one from the calcium. So there's 8. Because it took 2, again, it's going to be a 2 minus or a -2 charge. So that's going to be calcium. Calcium sulfide is what that's called. The next one we have, again, is between potassium, which is 1 dot. It's an alkali metal. And oxygen, which of course has 6. 1, 2, 3, 4, 5, and 6. Okay, we're going to add those two together into an ionic. Since, again, we have 1 for potassium, 6 for oxygen, this potassium one is going to move there. So let me go ahead and start drawing this. We're going to have our calcium here. It's going to lose its electron, so it has no dots, which will mean it's a plus charge, +1 charge. Here is my oxygen. It has 1, 2, 3, 4, 5, now 6, and a 7th. Okay, so that's a negative charge, but oxygen needs 8. That only has 7, right? 1, 2, 3, 4, 5, 6, 7. So we need 8. So the only way around that really is to add another potassium. If we add another potassium, then this electron can go right there. So let's go ahead and see if this will work. I'm going to add another potassium. It's going to have no dots. It's going to give up its electron, so it's positive, and its second electron, or its other electron, will go there. So now the oxygen has 8. So we have 2 potassiums that both gave up its only valence electron. Oxygen started with 6. It needed 2, so it took 2 potassiums for each 1 oxygen. So this now becomes a -2 charge. So that's 2 potassiums for 1 oxygen because, again, took 2 potassiums, valence electrons to fill the octet of the outer valence energy level of oxygen. So there's our answer in the right in blue. The next one we have, it says draw the Lewis dot structure for a compound between magnesium. So magnesium, of course, is Mg. It has 2 dots. And a fluoride ion, so to add a fluorine. 1, 2, 3, 4, 5, 6, 7. Okay, so magnesium is going to give up one of his right here. So that's going to be, let me draw that. We're going to have a magnesium here. It's going to have, so far, 1 dot, which means it's only a +1. And then we're going to have a fluorine with 1, 2, 3, 4, 5, 6, 7, 8 dots, which makes it a -1. But that's not right because magnesium still has 1. And it still has this one right here, and it doesn't want that one. So the only way around that is to add another fluorine. So let's see if this will work. So let's add another fluorine. So it already has 1, 2, 3, 4, 5, 6, 7. So if we move this one here to this fluorine, let's see if that works. So by doing so, we're going to add another fluorine here. 1, 2, 3, 4, 5, 6, 7. Then it took the second electron from the original magnesium, so it has 8. So it has a negative charge because it just took another electron. Then I'm going to remove this dot there, which would make this a +2 charge. So there we go. That's how it's going to work. It's going to take 2 fluorines. Each have 7. They could only take 1 more. The magnesium is going to bring 2. So it's going to take 2 fluorines for every 1 magnesium. See how that works? Each fluorine can take 1 because it has 7. The magnesium is going to bring 2. So because magnesium has 2 to get rid of, it's going to take 2 fluorines for every 1 magnesium. I'm doing a thing here that I want you guys to notice. Okay, this is going to be important in the next video, what I'm doing. All right, let's move on to a little bit harder one. So this one might need a little bit more space. All right, we're going to have a ionic compound between aluminum and bromide. So aluminum is Al. We know that it has 3 dots because it's in the 3rd column underneath boron. And we're going to add that to a bromide ion, which of course has 7. 1, 2, 3, 4, 5, 6, 7. It has 7 because it's a halogen. All right, so looking at this already, this is going to be kind of interesting. I could tell that this one could move there, and that would satisfy the bromine. So we're going to have an aluminum here. Currently, it has, let me take that back because I don't want that dot there to confuse anybody. Currently, it's going to have this dot and this dot. It has a +1 charge because it only gave up 1 electron. And then we're going to need a bromine here. It's going to have 1, 2, 3, 4, 5, 6, 7 of its original, took 1 from the aluminum, so it's going to have a -1 charge. That's still not working. So what we're going to need, again, why it's not working, just so I make sure I'm clear, is because of these. Those should not be there. So that's what I'm talking about when I'm saying it's not working. So maybe we could add, kind of like our magnesium fluoride, is if I add another bromine. Sorry, I'm out of space. I'm gonna have to move this down to the next row. I'm sorry about that, guys. Normally I'd put it to the right. But bromine again has 1, 2, 3, 4, 5, 6, 7. So I can then take this one here, that electron. So to make this over here, I'm gonna add another bromine. 1, 2, 3, 4, 5, 6, 7 of its original. Took 1 more from the aluminum, so it's gonna have a negative charge. What that's gonna do is it's going to take away this electron, and its charge will double to be a +2. Okay, we're getting closer. Still not there though, right? We're still not there again because we have that one, which is the same one as that one. So those must be taken care of. So if you notice my pattern, you probably already figured out what I need to do. I need to add another bromine. Now again, I'm putting this to the left only because I'm out of space. I'm not trying to make any geometrical pattern. In ionics, there is no trigonal planar, trigonal pyramidal, there is no tetrahedral, none of that, okay? I'm just putting them in different places on the left of my screen because literally I don't have a lot of space to put it, okay? That's all there is to it. I would put them all on the line, aluminum, bromine, 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 but again, just please bear with me. This is purely for space. Okay, so now that I'm taking that last valence electron from the aluminum, what I need to do is add another bromine. It's going to have its original 7, 1, 2, 3, 4, 5, 6, 7. And then it's going to take the last one from the aluminum, which gives it a -1 charge. I'm going to take away this dot here because it's now been taken to the last bromine, which gives it a +3 charge. So notice one aluminum had 3 valence electrons, right? Bromine had 7 and it only needed 1. So because aluminum had 3 and bromine can only take 1, it took 3 bromines for every 1 aluminum. Okay, I'm going to show you guys that again because like I said, this is important for the next video. The aluminum had 3 valence electrons to give away. The bromine each had 1. So aluminum had 3 dots, the bromine needed 1, so it took 3 bromines for 1 aluminum. Okay, that's important. All right, I'm going to go ahead and clear up a little bit of space here because I need to do my last example and I'm going to need some more space again. Okay, this last one is even a little bit harder. So what we have is another ionic compound between barium and nitrogen. This time I'm going to try to do it a little more correct. I'm going to save myself some space and try to write a little bit smaller. I'm going to do it all linear as opposed to kind of going in different directions, again, because I don't want to confuse anybody. So over here, we're going to start with our barium atom, Ba. It has 2 dots. And then we're going to add it to a nitride, which has 5 dots. 1, 2, 3, 4, 5 dots. All right, so think about that. Barium has 2. Nitrogen or nitride, because it's going to be an ion here in a minute, has 5. That's weird. So we're going to have to make this work somehow. So let me go ahead and put my barium here. All right, so the barium is going to go ahead and give up. Let's go ahead and just take a stab at this. I'm going to move one there. So that's going to, the left side's full. I'm going to go ahead and move this one, let's just say over here to the right side. So the right side's full. So that means barium has now lost both of its dots. So it has no dots here, and it has a +2 charge, or 2 plus, same thing. Okay, then I'm going to go ahead and add my nitrogen. My nitrogen has 2 on the top, 2 on the right, 2 on the left, and 1 on the bottom. Again, I don't want to confuse anybody, so let me take this little spot out right there. That was not a dot, that was just a poorly drawn in. Okay, so my nitride currently has 7 dots. It doesn't have 6. So you guys know the pattern. If nitride has 7 but needs 8, I'm going to need another barium, right? I'm going to need another barium. So let's go ahead and add another barium. Barium again has 2. So let me go ahead and let's see. If we move this one down here, then my nitride is full. Okay, so that's good. My nitride is now full. There's the second dot, and that's going to give it a -3 charge because, again, we had to take 3 electrons from 2 different barium atoms to fill its octet outer energy level. Okay, so we're getting somewhere, but now we have another problem because our barium has an extra. So let me add my barium. So my barium currently is this. That's not quite right because my barium has an extra. So if that's not right, well, I guess we need to add another nitride. Nitride has 5. 1, 2, 3, 4, 5. Okay, so I'm going to add my nitride over here. Okay, well, let's see if this works. My barium is going to give up one of its valence electrons over here. Okay, so let me go ahead and complete that over here. I have 1, 2, 3, 4, 5. I'm going to get a 6th right there from that barium atom. So what that does is it's going to give this a -1 charge currently. I'm going to change this charge and take away that electron. So of course its charge, like the other one, is going to be a +2 or a 2 plus. Again, same thing. All right, so we're getting closer. The problem is my nitride only has 2. Okay, so what I mean by 2 is it only has this one and this one, which are still individual, which is the same one as that one and that one. So something must be done about that to fix that. So you might be able to figure out that what I need is yet another barium. Let me go ahead and move this, guys, real quick, because I'm already running out of space. I was trying to be so careful, and I'm already out of space. I'm going to squeeze this in real tight here. Barium +2. Okay, I'm going to add another barium over here. Barium, as you know, has 2 dots. So if I do that, this one can go here, this one can go there, and that looks like it should work. So let's see. I'm going to add another barium. I'm going to squeeze this in. Sorry, guys. It has no dots because, again, I just drew in red arrows. That's going to give up its only 2 electrons, so it gives it a +2 charge, just like the other bariums, which means I need to add another nitrogen over here. Again, it came, oh, excuse me, no, I don't. Sorry, guys, what am I talking about? What I need to do is add 1 dot, 2 dot, which would change this charge from a -1 to a -3. And there we go. That's right, because barium, all 3 bariums have no dots, which again, they shouldn't because they're the metal. They're going to lose their electrons, so they should have 0 dots at all. The nitrides, on the other hand, are the nonmetals. They're more electronegative. They're going to be the anions. They have 5 dots already, so they need 3 more dots, which gives them a -3 charge. So to do that, it took a barium with 2 valence electrons, and it took nitrogen, which needed 3 valence electrons. So barium had 2, nitrogen needed 3, so it took 3 bariums for every 2 nitrides. Again, just to say that one more time, barium had 2 valence electrons, nitride needed 3, so it took 3 bariums to satisfy the 2 nitride ions. There we go. So it's going to take 3 bariums for every 2 nitrides. Where am I coming up with nitrides? Nitrides in order to satisfy a compound we call barium nitride. All right, and that's how you draw ionic compounds.